Hello Year 5s and welcome to our fifth and final online lesson on place value to 10 million. You will see I have a new background, trying something new for Friday, fresh for Friday. Let me know how it goes and whether or not you're having any difficulty seeing the screen. Feedback is always good. Okay, let's start as normal with our maths meeting. 100 minus 14, 9 squared. The superscript 2 there means it's 9 squared, which means 9 times itself twice. 9 times 9. Column subtraction, column addition, lining up your decimal points carefully, and then a column multiplication. 5 times 1, 5 times 90, 5 times 200, and 5 times 4,000. Pause, and off you go. Let's look at the answers together in 5, 4, 3, 2, 1. When I've been looking at your work this week, it's been very accurate. I'm going to have to give you a little bit more of a challenge next week, I think, for these. Okay, let's go on to answers from yesterday's work. We're using the symbols smaller than, equals to, greater than. Got millions here, 6 million compared to 4 million. Of course, 6 million would be more. It's a 6-digit number. It goes to hundreds of thousands, whereas this is a 5-digit number going to tens of thousands, so we know the 6-digit number will be larger. This number is a 6-digit number. It has no millions, whereas this is a 7-digit number. It has got millions, so we know it will be bigger. These two are both 6-digit numbers. They both have 900,000 in them. However, this has no tens of thousands, hundreds, tens or units, whereas there are tens of thousands, hundreds, tens and units, so this is the larger number. Then you're asked to order these from smallest to largest. The smallest are the 6-digit numbers starting with 200,000. Then we've got 3 6-digit numbers starting with 300,000, 302,000, 320,000 and 330,000. And then we have our millions, which are greater, 2 million followed by 3 million. Ordering the next set of numbers from smallest to largest. Again, we've got 3 5-digit numbers here, 500,000, 509,000, 900,000. And we've got our 7-digit numbers here, 5 million, 9 million. We know 9 million is going to be the biggest. Again, I don't think any of you will have any problem with that. You're all doing brilliantly with this. So our next part of the lesson, we're going to recap what we've been learning all week. So you need your pen and paper ready, play along, pause if you need to. I will try to put some pauses in that should be long enough for you to write the answers down, but if you're struggling, please do pause and have a go. So Monday, we learnt to read and write numbers to 10 million. Have a look at this number, spot the millions, spot the thousands, spot the hundred, tens and units. Have a go at saying it. And let's say it together. It's 3,200,927. Our next example, there aren't any millions, it's only a 5-digit number. Hundreds, tens, units. There are our thousands. Have a go at saying it. And together, it's 54,000. Third and final example. We're experts by now. No millions for this, it's only a 6-digit number. Got the thousands here, the hundreds, tens and units. Have a go at saying it. And altogether, 251,000. Good job. On Tuesday, we were recognising the value of digits up to 10 million. So I'm going to show you some numbers and I would like you to tell me what the digit 3 represents in each of these numbers. What is the value of the digit 3 in each of these numbers? First of all, let's read it together. 4,023,000. Spot where the 3 is. Either write it or say it. It's in the 3000s. Well done. Our second number, we've got 3,829,519. Find the digit 3. Whereabouts is it? Say it, write it. Let's look together. It's in the millions column. It represents 3 million. Third and final example, 5,030,820. Spot the 3. Let's have a look. Units, tens, hundreds, thousands, tens of thousands, hundreds of thousands, millions. Whereabouts is it? Say it, write it. Let's look together. It's in the 30,000 spot. It's in the tens of thousands, so we say it's 30,000. Well done. We're now up to reading and writing numbers from the words themselves. So let's read this together, and then you can write down the number on a piece of paper. 4,793,108. So write that down in digits in your book. 4,793,108. Let's look together. 4,793,108. The next example, 29,300. 29,300. Write it down in your book. And we'll look together. That's 29,300. There's no millions, there's no hundreds of thousands in this number. It's a 1, 2, 3, 4, 5-digit number. Our final example, 2,500,000. 2,500,000. Let's have a look together. Got 2,500,000. Do need to have these zeros in here to show that there are no thousands in this number. It's just 2,500,000, but without these zeros, it would look something like 2,500, which is a very different number. Okay, on to yesterday's lesson. Order these from smallest to largest. So get your piece of paper, have a think about it. These are 5-digit numbers. Got a couple of 7-digit numbers and one 6-digit number. So straight away you can start looking for the smallest ones. Pause if you need to. If not, let's reveal the numbers in 5, 4, 3, 2, 1. The smallest is 45,000 and 54,000. Our only 6-digit number, 540,000, 4,500,000, and then 5,400,000. I'm purposely using 4s and 5s there to make it just a little bit trickier for you. Okay, let's go on to some problem solving, because by now you are experts. I've got 3 problems to solve. You need to solve these along with me and take a picture of you solving them to put onto Dojos. Okay, so the problem is that I'm thinking of a number, and the number is made from the digit cards above. So I've got the digits 0, 2, 5, 7, 9, and they can be arranged together to make a number. Let's look at our clues. First of all, it's a 5-digit number. Well, there's a 5-digit number. It's going to have units, tens, hundreds, thousands, and tens of thousands. It's not going to have hundreds of thousands or millions. It's a 5-digit number. That's handy because there's 5-digit cards there, isn't there? My next clue is that it's even. Now I know that even numbers end in 0, 2, 4, 6 or 8. It is worth less than 60,000. If it's worth less than 60,000, it can't be 70-something thousand or 90-something thousand. And the sum of the digits in the thousands and the tens of thousands column is 12. There's the tens of thousands, there's a thousand, so whatever digits go into here, they must equal 12 if they're added together. And the final clue is that there are no tens. Okay, have a go. Pause the video, have a go, and then we'll work it through together in just a moment. Okay, by now you should have had a go at putting these into the right order to try and find the number that I'm thinking of. Here's my explanation on how to get there. So first of all, it's a 5-digit number. We're ready for that. It's even, so we know it's going to end in 0 or 2. It can't end in 5, 7 or 9. So this number here must be in the units the 0 or the 2. There's another clue that will help us. It says there are no tens. Well, if there's no tens, there must be a 0 in here, which means the units must be 2. That's my first part. I can get rid of the 0, get rid of the 2. It's definitely going to be an even number. There are definitely no tens. So the next clue I can look at is it's worth less than 60,000. Well, if I put a 7 in here, in the tens of thousands, it would be 70-something thousand, which is bigger than 60,000. If I put the 9 in here, in the tens of thousands, it would also be bigger than 60,000. So I know it must be 50-something thousand, and I can put that in. The sum of the digits in the thousands and the tens of thousands column is 12. So I know that 5 plus something must equal 12. Which is it? 5 plus 7 is 12 or 5 plus 9 is 12? I know that 5 plus 7 is 12. So I know that in the thousands column, the 7 belongs. And that leaves me with just the 9 to put in the end. I can double check. Yep, it's a 5-digit number. It is even. It is worth less than 60,000 because it's 57,902. I know that the sum of the digits in the thousands and the tens column is 12. 5 plus 7 is 12. And I know that there are no tens. Let's have a look at our next example. Okay, I'm thinking of a number and it's made from the digit cards above. Got a 0, 0, 0, 2, 2, 3 and 7. It's a 7-digit number that we're looking for. So this time it's going to have units, tens, hundreds, thousands, tens of thousands, hundreds of thousands and millions, because that makes it a 1, 2, 3, 4, 5, 6, 7-digit number. The digits in the tens and units are both odd. The tens, units. I know which of these are odd. It has an even number of millions. I know which of these cards are even, and they're going to go into the millions. It doesn't have any thousands. So I can figure out what goes in the thousands. If you add the digit with the highest value, well, that will be the millions, to the lowest value, that will be the units, it equals 5. Pause a moment, see if you can figure it out. Okay, by now you should have figured out an answer. Might not be the right one, or you might have only got halfway there, but well done for trying. Let's have a look together. Okay, we've got as far as it's definitely a 7-digit number. The digits in the tens and units are both odd. Well, 0, 2, 3, 0 and 2 are not odd numbers. 3 and 7 are odd numbers. So that tells me that the tens has either got a 3 or a 7 in, and the units have got either a 3 or a 7 in. We might have to use some of our later clues to figure out which way round that is. My next clue is that it has an even number of millions. Well, my number can't have 0 millions because you wouldn't bother saying it. So it must have 2 million. It doesn't have any thousands, any tens of thousands or any hundreds of thousands. So I suppose that's the 3 zeros going into that space. No thousands at all. Finally, if you add the digit with the highest value to the digit with the lowest value, it equals 5. The highest value is 2. The lowest value is either 3 or 7. Well, which of those do I add together to 2 to make 5? I know that 2 plus 3 equals 5. So it must be 3 in the units, and that means it must be 7 in the tens. My last digit card left is the digit 2. And that I'll have to place into the hundreds. Let's double check. Is it a 7-digit number? 1, 2, 3, 4, 5, 6, 7. Yep. The digits in the tens and units are both odd. 7's an odd digit. 3's an odd digit. It has an even number of millions. That's 2 millions. That's an even number of millions. Doesn't have any thousands. No thousands whatsoever. And if you add the digit with the highest value to the digit with the lowest value, it equals 5. 2 plus 3 equals 5. That must be the number that I'm thinking of. Good job if you got that one right. Here's our third and final example for this week. I'm thinking of a number. It is made from the digit cards above. 0, 4, 5, 5, 7 and 8, and it is a 6-digit number. It will have units, tens, hundreds, thousands, tens of thousands and hundreds of thousands, because that makes a 1, 2, 3, 4, 5, 6-digit number. It is even. I know what a number has to end in. I know it will have to be in the units to make it even. The digit in the tens of thousands is double the digit in the units. So the digit in the tens of thousands will be double the digit in the units. The same digit represents the hundreds of thousands and thousands. So the same digit in the hundreds of thousands and the thousands. And there aren't any tens in this number. Pause and have a go at figuring it out. Well done if you've managed to figure it out. Good job. Let's figure it out together. So it's a 6-digit number. We're ready with our place value chart to put that in. It's an even number. Well, if it's an even number, it's going to end in 0, 4 or 8. That's 3 options there. 0, 4 or 8. I haven't crossed them off yet because they're going to belong in somewhere else. The digit in the tens of thousands is double the digit in the units. So the number in the tens of thousands has to be double something in the units. Well, double 0, 0, could be that. Double 4 is 8. That would solve our problem. Let's try it. So we put the 4 in the units, it's still an even number, and an 8, which is double 4 in the tens of thousands. Let's carry on. The same digit represents the hundreds of thousands and thousands. So what digit could it be in here and in here? If we look at the digit cards, the only option we really have is 5 and 5. It's the only ones that are the same. So let's put them in. Then it says there aren't any tens. So if there aren't any tens, it's going to be represented by a 0. And that means we're just left over with a 7, which must go in the hundreds. Let's put that in and double check our answers. It is made from the digit cards above. Check. It is a 6-digit number. 1, 2, 3, 4, 5, 6. Check. It is even. Ends in a 4. It is even. Check. The digit in the tens of thousands is double the digit in the units. Double 4 is 8. Check. The same digit represents the hundreds of thousands and the thousands. Both the same? Check. There aren't any tens. Check. So the number I'm thinking of must be 585,704. Well done if you got that right. And that's the end of maths this week. I hope you've enjoyed learning about larger numbers. If there's anything you're a little bit stuck on, please do let me know. If not, upload your pictures of your work for your dojos and we'll be back next week. Have a lovely weekend.